Hello, welcome to today's LeetCode problem solving session. Today's problem is 75, sort colors. Let's read out the problem first. Given an integer array nums with n objects colored red, white, or blue, sort them in place so that objects of the same color are adjacent with the colors in the order red, white, and blue. We will use the integers 0, 1, and 2 to represent the color red, white, and blue respectively. You must solve this without using the library's sort function. So I think this is a really interesting problem. It could be considered easy or medium depending on how you see it. I think in general, implementing a sort function is not easy. It's definitely not hard, or like if someone has done it, like has been coding algorithms for a while, it's definitely not even medium. You could just write mod sort, right? But or you could like even do bubble sort, considering the constraints. It's just 300, and yeah, and that's actually what I think makes this problem really interesting. Uh, it's I think you can just basically take counter, or like you could assign an array of size 3, call it, maybe it looks like this at the start, and then you could just go over the uh, array once, basically counting every, uh, like incrementing the element at that index by one. Every time you see something, you see that specific color. So basically that's like the counter approach. Um, And yeah, you are doing everything in one pass, and then basically once you have the counter, you can just turn that back into an array. You can either create a new array, or you could just modify the original array, since just a leet code problem. It's not real life. So yeah, now we have that in mind. We can solve it in no time, so that's pointless. I don't want to waste any time. I want to actually look at this follow up. Could you come up with a one pass algorithm only using constant space? And I think this is what makes this problem really interesting. So it's asking us, one, to use a problem one pass, and then only, so that means you just use one for loop and you go through the array only once, and using only extra constant space. And actually using something like this is, I would consider, extra constant space, right? So let's see how we could actually do that. I actually don't have the proper idea in mind. I'm kind of talking through it, talking out loud, and hoping I could get through this. So I'm thinking of some kind of pointer solution based on I've solved this problem before, and I think based on what I read before, I think it's basically some kind of pointer problem. So we s- have two pointers, one at the start, one at the end. If it's two, we basically send that to the end. Mm, and if something's one, maybe we could use like a variable to keep a count of one, and we could do it like a left less than right solution, and once we get to a point where right is less than left, we could like start there and we could start populating the number of ones, maybe. I mean, that's not exactly a two pass, like a one pass solution. We just have zeros and ones or something like that. We could end up, yeah, if we have like zeros and ones, we probably gonna be doing a two pass anyway, because we would not move the right because we have no twos. We just have zeros and ones, and we keep going till the end, counting zeros or like placing zeros. And then once we reach the end, we're gonna come back a little bit, placing the ones again. I don't think there's anything important in the hints. I think I've seen them before. So it's two pointers. I think what I'm thinking of is two pointers. It's just do what I was thinking about, and then maybe we can come up with something even better. We call left and right as zero and up zero and the length of nums minus one, while left less than right. We keep a count for ones. Let's call this. Let's make the zero. Uh, if, if nums left is equal to 2, let's just place it at the right. We can kind of swap it basically. Once we swap it, let's not move the left yet, because what if we have 2 on the right? We don't want to miss that. Else we do, okay, lf nums L is 1, we basically increase counter for 1, and let's place a 0 here, I guess, yeah. Once we kind of break this, while oh, mhm. Seems like we're getting stuck in some loops here. Okay, so we can see that we moved this to zero, and the zero is fine. We move this to here. Okay, so I think the issue is that since this L and it's basically the loop is breaking here and this is not being counted. Hmm. Yeah, we're gonna start with R and move R. Yeah, because L goes to much to the right and R kind of we don't move R unless we let's say we are in replacing the twos. Yeah. Mm. Okay, I've done this a while ago, but yeah. Uh, but still this is still not. Yeah, this is still not one pass. Let's try to visualize something. Neat color, bro. Neat color. Need a pattern. A pencil? Yeah, this is fine. This is not a bad test case. I think this is a pretty good test case. We basically kind of have to account for ones as well. So instead of two, let's have three pointers. Let's put one here, and let's put one. We put one right here. Uh, We start here. I think we should do something like basically I want to start here, and since this is two, we put two here. We move this to the right. I mean left. But if this is right, I think what I need to do is hmm, call right, left, and middle. Left dot. If this is two, then we kind of check if this is one. If this is one, we basically have to do a bunch of things. Mm-hmm. Basically move both to the left. I think we should do if it's not equal to zero, like if it's not equal to one, I mean, because even if it's two, I don't want to. I kind of want the same behavior, and else we let's say if this is if we're here and we have so now we have a zero here, right? And we have a two here. Delete this. Change this to two. Change this to a zero. Right off. We have left here, right, and then here. This is not gonna nothing's gonna happen. Let's say we're here, right? What we kind of need to do is we kind of need to do a three-way swap where one we move the two here. Mm-hmm. Basically move the two here. Yeah, kind of expecting the same behavior, aren't we? Yeah, I don't think it matters, does it? It really doesn't matter. Just swap is, is equal to. Hmm. Names L is one. I really don't know if it's gonna work. I think I'm making a huge logical mistake here, but yeah, just swap it. M and we only move M. Yeah. Let's see what if we make a mistake, what it is. Oh, we did not. This worked. Let's create a more complicated test case. Mm, oops, not too complicated. It has to pass the validation. Mm. I think the number of zeros and ones are the same. So the data is not getting lost. It's just that the solution is not correct. So we have four zeros here. We have four zeros here. Which with this? Okay. So length is the length. We start 14. R comes down until 1, 2, 3, 4, 5. Okay. Let's go from here 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. R comes down to here. Yeah, M is at 2. M kind of traveled down too far, didn't it? I think we only move this if M and R are the same. Okay, too bad. Why do we always need to move R? That doesn't make sense. Oh, wait. We do this first because we're. Oh, I found our issue. I think this should be. No, stop. Print too much. But yeah, I think I printed too much. But yeah, I think this is basically one pass. Kind of running better than the previous one. Not really sure. I assumed that this would take more time, but maybe it's that initialization of loop maybe take have a lot of overhead because we're using Python and having a lot of such insights since I've been using C++ a lot more. But not sure why. Okay, this did not get updated here, but now it did. So we're good to go. Thanks for watching. Peace.